All right, welcome back to Problems Solved. Here's another example that we're going to be looking at in order to try to figure out whether the statement is true or not. All right, let's look at this one. All the problems are from our book, so I highly encourage you guys to sort of, even if those problems were not assigned, just go ahead and do those just so you have enough experience with them. So once down to 15, the world's only wild flock of whooping cranes now numbers a record of 237 birds in Texas coastal bend wintering ground, and the average whooping crane egg weighs 208 grams. A new batch of randomly selected eggs was recently weighed, and their weights are listed. So here we have some weights of our crane eggs over here. At alpha equals 1%, is there sufficient evidence to conclude that the weight is greater than 208 grams? Assume the variable is normally distributed. Okay, so we have here few eggs. Okay, I see here n equals 9, right? So at it being a small number, we need to know whether this is normal distribution or not. And this is what they tell us. Assume that it is normal. Okay, so fantastic. So what is that parameter that we're talking here about, right? The parameter for us drives the type of test I am going to be performing. So we are talking here about the mean egg weight, right? We'd like to know what is the egg weight here, whether it is greater than 208 grams or not. So first of all, I highly recommend that you put these values either in Google Sheets or Excel, figure out your mean and your standard deviation. And second thing, go ahead, pause the video and state your hypothesis. So the parameter that is going to drive for us this test is first of all and foremost is going to be the mean weight. Okay, the average weight is going to be our parameter. So the average is mu, and in the status quo, the mu is 208 grams. In the alternative world, we hope that it is greater, okay, than 208, and alpha is 1%. Okay, so this is a one-tail test, okay, and in this one-tail test, we are looking at the upper reaches of this, and alpha is only 1%. Okay, very good. So the question here, this is the mean. Am I doing a z-test or a t-test? I would do a z-test if I had the population standard deviation. But they don't give me any standard deviation, not just a population standard deviation. But from these values over here, I can kind of go and figure out my observed mean from these eggs, and I can also do the standard deviation of the sample. Okay, note that I round to 2 places after the decimal because we always do one additional place. Since my data had 1 place after the decimal, then my mean and standard deviation are now going to have 2 places after the decimal. Okay, since I have to use my S of x, my standard deviation of the sample, that means that this is going to be a t-test for the mean. All right, you can go ahead and calculate your t-statistic. So pause here and do that, and come back and compare that with me. Okay, so what I have there, I have observed 209.74 minus 208, which is the hypothesized. All right, and then my standard deviation is 1.67, and I'm going to divide that by the square root of 9 because my sample size was 9. Okay, I go ahead and do that, and I end up with 3.126. So I can round that to 3.13. Or you can also leave that as 3.126. It doesn't matter. The t-table does have 3 places after the decimal. Now, I'm just going to go here and perform the t-test what is the probability of getting such a t-value or greater? And this is, I do that in one of those online calculators. So in this online calculator, first of all, you don't see a curve here, and that's because you need to fill in the nu, okay? The nu is essentially the degrees of freedom. I had 9 eggs getting weighed, so I have 8 degrees of freedom. Once I have that, there you go, there is my curve. And my t statistic that I ended up with was 3.126. Okay, and it is greater than because that was a right tail, and the probability for that is 0.007. Okay, less than 1%, 0.007. So this is 0.007. Now, in the p-value method, we are comparing our p-value to our alpha. My alpha here is 1%, and my p-value is less than 1%. That means that it's even smaller than that 1% that I was willing to make type 1 error. Okay, so this is, it does look significantly smaller. Okay, or actually we should say greater, because it's, if the mean weight is 208, that's my hypothesized mean, we are actually ending up really far away from the hypothesized mean. Okay, and therefore, since our claim was, is there sufficient evidence to conclude that the weight is greater, as we are able to reject our null on the base of our evidence does suggest that the weight is greater than 208 grams. Okay, so again, we are rejecting the null, and once you reject the null, the alternative has to come into place. Okay, and our alternative, I forgot to put this here, but our alternative was our claim in this case. Alrighty, hopefully this is clear, and if not, always feel free to put comments in the video, and I will try to do my best to elucidate them.